My name is Isaac. I lead the solutions engineering team in Americas.
And I do the same thing. My name is Vitor. I do it over across the pond. I lead solutions engineering in EMEA. So Isaac, do you want to tell folks what poolside is all about?
Yeah. So poolside, we've been building the next generation AI for software engineering. We believe that software is a very specific and unique domain that requires its own intelligence. Poolside today is a full stack solution. So what is poolside? At the base layer, we've created a new foundation model from scratch, a new large language model specific to software development. We fine-tune, we take that model, we fine-tune on code as well as developer interactions. That way the model understands your business, is relevant to your business, and then we deploy it within your security boundary so that you have the comfort that data never leaves your security zone. But I have a big question for you all. Why would we create a new foundation model? Why would we create a new large language model? In fact, to go even further, why does poolside even exist? This is a very competitive market. Why do we exist? Vitor.
So poolside was founded on 3 core convictions, and you see this all over our material. First is that we think that the future belongs to domain-specific models. And a lot of leaders in the industry agree as well. For example, if you look at self-driving, self-driver doesn't use general large language models. It needs to be very specific and good in turning on that left turn without crashing with cars. So we find that excellence lies in domain-specific. So that's one reason we had to create new foundation models. Secondly, like Isaac just said, when we talk to customers, most say that this is great and this is helpful, but for my 10-year-old code base, it's really not relevant. Like, it's good on greenfield projects, etc. And third, because we adopted AI faster than anything before, we had to make compromises in the amount of data we're happy to send out to the cloud. So with more and more data getting broadcasted to the service to do the inference, we believe that that data pool is only going to increase, and at some point you're going to have to send most of the data to the models for inference that you have. So Isaac, based on these 3 pillars, can you go a bit deeper on the first one?
So general models will always be limited for software development. Let's back up a couple of years. So 3 years ago, we started to realize as an industry that generative AI is possible. So quickly we landed in code assistance land. That's what we generally have today, code assistance. But we at Poolside believe the future is much grander for software development. We believe that AI is going to become a junior developer. It's going to become a senior developer, all the way to the point where AI is a product and development team. Now, humans may be directing that AI, but this is actually where we're going. But there's a big problem. There's a big chasm today between code assistance and AI becoming a junior developer. And our contention is that general LLMs are not going to be able to cross that chasm. We've been in code assistance land for 3 years. We're still very far from AI becoming a junior developer. Well, why is that? Models are not categorically trained for software development today. We like to say that models today, the general models, they understand software development just as much as they understand French literature, as they understand how to change a tire. There's no specificity in software development. And when we actually look at what the models are doing, we like to say this a lot, they are taught about code, but they don't know how to code. And so the difference over here is the equivalent of reading the textbook on coding. But anybody who's coded a day in their lives knows that it's not enough to just read the textbook. You actually need to code in order to learn how to develop. So we have this problem today. Well, Poolside's focus is solely on software development. which means since we create our LLM from the ground up, we can make very different architectural decisions on how we build our LLM as opposed to others who are building a more generalized large language model. But as some of you may know, if you are building a large language model, that's not a very easy task. Vitor, can you talk us through some of the factors involved in building an LLM?
So, if we strip away a lot of the complexity of building a model, which has a lot of intrinsicy, there's two big things that matter the most. It's compute and data. So how does poolside address both of these challenges? In terms of the compute, louder. In terms of the compute, can you change? Our recent Series B that allowed us to raise $500 million gives us most of what we need in regards to computer. So a lot of our funding was translated directly into procure GPUs for the next 3 years so we can be in the forefront of building frontier models. At poolside, we see this as a responsibility, as a privilege. We understand that this is a restricted space and we were given this opportunity, so we want to use that to advance the technology forefront here. The thing is, when you look at this list of kind of the top companies with allocated GPUs across the industry, there's one thing, and that matches what Isaac said before, that separates poolside, is that our focus on this list is software only. So while you see, for example, Meta or Tesla driving, Google, very generic LLMs, OpenAI, we focus specifically on software development. But that's the easy part, I guess. Next. Because everyone here could argue, if you have enough money, you can procure the compute and that's it. But the funny thing is that you cannot do the same with data. I can pass you a check and you will not be able to procure high quality code data. From all the data that exists in the world, if you go to GitHub, GitLab and other sources, only a very small fraction of that data is useful for training. So if you think about scaling laws and how you can grow the compute, the size of the model, we have a problem here on the data side of things, where you can't buy more data. You can't grow this infinitely. So boiling it down to simple, next one, if you want a good model and if we want to reach the capability that Isaac was talking before and beyond, you need data. But how do we solve that problem? We know that there's always code being written every day, but it's not enough for the models we want to build. So this is something really unique about what we did, and Isaac will explain now how we solve this challenge.
So what data exists out there? There's a dirty secret in our industry. All the LLM providers are training off of the same code data today. It's the open source data. Right? You go to a data aggregator, and the data aggregator has all the open source code out there. But that's only a subset of the necessary information. If we think about the data, the open source code, all that is the end result. Think about how much thinking went through your mind only to get to the end result, which is the code. So we can look at the problem, and we could look at the output code, but we don't understand anything in between for that thought process, which is why you're kind of stuck with next token prediction today. This is, again, what we term learning about code. It's the equivalent of reading the textbook on all of the available code out there, but you still haven't learned how to code. You haven't learned how to think. And so this is why we've developed RLCEF, reinforcement learning via code execution feedback. This is our secret sauce to creating large language models specific to software development. So you may already know the reinforcement learning part. It's the code execution feedback part that's super unique to us. Well, going back to that question of how did you learn to code? Well, I learned how to code by coding, by hitting the compiler 100 times and then finally getting that one time that it works. Well, every time that I write a line of code, I have a mental model of what I expect. I'm asking myself, is this code going to compile? Is it going to pass unit tests? Is it efficient? Is it secure? All of those things are going through my thought process. This is what we term as chain of thought reasoning. This is how we learn to code. But how do we train an LLM how to code? By executing the code. It's the only real way, because this data doesn't exist anywhere. So we need to execute the code. Reinforcement learning via code execution feedback. So how does this work in practice? And how do we do this at Poolside? Well, we can look at the top open source repos. The top open source repos today have high quality code, and they also have valid tests. They also have unit tests associated with them. And so what we can do is we hide the code, and we tell Poolside, we want you to code against these repos. Because code is deterministic, we can understand whether the code that Poolside had written compiled, whether it passed tests, in the future, whether it was vulnerable by running vulnerability scans. This is how we get the data to train our model how to code, just like a developer would be learning how to code. But the key over here is that we've done this at a massive scale. We've done this now on over 500,000 open source repos, commit by commit. We actually had to create a Heroku-style test bed, so that way we can execute JavaScript or C++ and hide the code at will via API. This is our secret sauce. This is how we train our model to think about code, to actually code. Vitor, can you summarize that for us?
I can. And before that, it's important for you to know that the process that I just described is completely automatic. So the selection process, the execution process, the evaluation process happens in the background, and we're doing that for around 500,000 repositories. And that's part of a lot of the time we spend, because now we just need to scale up this factory, and it just continues generating that synthetic code. So at its core, we're teaching our model how to think like a developer. And by generating unlimited synthetic data, we're just not increasing quantity of the data, but we're building a model that truly understands software development patterns and principles. And this is how we think we'll make that jump. So today, if you're a Poolside user, you are given two models, Point and Malibu. They're built from the ground up using reinforcement learning through code execution feedback. They can be fine-tuned on your code and data. And Point, for example, as a linear attention model, is around 10 times faster than comparable models out there. But if we show this slide to a customer, the only thing they retain and the only question that always comes up in every discussion is, yeah, I get it, intelligent models, but are they going to give me relevant suggestions and relevant answers? So we go back to the point of how relevant is this to my business?
And that's the other thing. Models don't understand your business today. We like to joke, it's like eggs. Imagine every day you wake up and you get eggs. And like you're excited the first couple of days, right? Somebody made eggs for me. I just had to wake up and I got my eggs. But by the third day, you start to say, I really want my eggs the way I want it. I wanted the sunny side up with mushrooms and onions. I don't want the same exact eggs every day. This is sort of like what we see with general models. They give you the same results back because they don't have the context, they don't have the understanding of your business. This is why the Poolside model is fine-tuned on a lot of different data sources. We use RAG as well as fine-tuning in order to fine-tune off of your code, your data, and your user behavior. So I'll give you a simple example. Let's say you're using an internal payments API. Well, the general model only knows about the payments APIs that exist out in the wild, in the open source. Well, the first thing that we'll do is we'll fine-tune off of your code so we understand that you have an internal payments API. The second thing that we'll do is as you interact with the model and you say, hey, I actually want to use the internal payments API, we're going to use that as training data set as well. So the key over here is that this model becomes, over time, your model. The model that understands your business. The model that deeply understands how you function. But we're not just delivering a model. In the future, what we see is delivering intelligence. You see, if we're giving you this model and we start to ingest other data sources, today we ingest code, but in the future, we start to ingest ticketing, SCM, all the way down to deployment, you start to realize that this intelligence that we're delivering, it knows more about your software business than any single human developer out there, because we fine-tuned all of all of these data sources. So we start to see that in companies in the future, they're going to have a new primitive that's been created, the software intelligence layer. In your company, the software intelligence layer that knows everything about your software that all other apps want to plug into because it understands the software business. Now there's one question you have to ask. If this thing knows more about your software business than a developer, than a human developer, would you ever want that to leave your four walls, to leave your security boundary?
So again, in my experience, we've adopted AI faster than anything else. Like it showed up and we all bought it. And that's probably because it was a bit of an arms race in terms of capability. If you have it, he needs to have it because he's now 5-10 times more productive. But like Isaac said, how much of this IP are we willing to send to the cloud? So I give you an example. In the short term, and I think everyone will agree on this, models will ask to be more capable, more and more data. So let's think about the payments API. I asked the model, help me complete this payments API. If you were a human, what would you do about it? So I would probably go check if someone talked to me on Slack about this. Maybe we had a conversation or a thread on Slack. Is the branch that I'm working on related to a pull request? I need the info on the pull request. Does the pull request have a Jira ticket associated with it? I want to see the Jira ticket. And then I want to crawl every link that was on the Jira ticket, including all the other Jira tickets. So that's much more than the 32K or 100K context we know that we do. And I think a lot of people are not understanding that you are going to demand a certain level of capability and quality of the answer, which is when that API response comes, it's perfect and you're just going to adopt. But you will have to open the floodgates of pretty much your complete developer ecosystem. So there is a trade-off. And one of our pillars, and we mentioned that at the beginning, is that we believe that you don't need to have that trade-off. If we give you the model, we allow you to do the fine-tuning on your network, and all the data circulation, all the inference, all the fine-tuning happens within your network. So today, we provide poolside in your AWS VPC. We give you everything you need to set it up, and you can consume the model, and all the data that propagates is under your control. So the key takeaways here to kind of summarize our talk is that we're building the most capable models for software development, and we explain how we plan on doing that with reinforcement learning through code execution feedback. It's fine-tuned on your data in your VPC, and it's your model, something that you can leverage with an API and build as many other applications for that model as you wish, because we also ship with an API. So, thanks for your time today. Thanks for listening. We are on booth 708, so if you want to see the product, you want to see a demo, you want to see what we've built today in terms of the IDE experience, the chat experience, we're there. We would love to get to know you a bit better and have a one-on-one chat. Thank you.
Thanks, everybody.